Welcome, .NET friends. This is another episode of the on.NET live show. If it's your first time tuning into the show, what we're all about here is empowering you, our .NET community, to achieve more with the technology. I'm your host, Scott Addie, and I'm joined by co-hosts Maira Wenzel and Cam Soper. So if you're like me, you hear these terms frequently, OAuth, OpenID Connect, or OIDC. You might hear auth flows, claims, tokens. At this point, my brain feels like it's melting, and I'm wondering, what does it all mean? Well, I'm happy to report that we're joined by our guest, Leo Micheloni, who is here today to help us all make sense of this. Leo, would you like to briefly introduce yourself to the audience?
Yes, sure. Thanks, Scott. Yes, my name is Leonardo Micheloni, and I'm a software developer in Spain. I'm from Argentina. I have a little slide with some other details, but basically, I will try to clarify some concept because it's the same as Scott. At first, it was very difficult for me to know exactly what is a scope and a flow and a grant. So that's why we are here. So that's it.
Yeah, and I feel like this is a scary topic. You know, many of us are asked by our managers, hey, just add auth to this application, make it happen. And again, we're kind of like, well, well, we recognize it's important, but we may not fully grasp the fundamentals of it. So, Leo, I know you have a slide deck you wanted to present to us today to kind of break down some of these topics. Why don't we start there?
Yes, sure. Let's get started. So, first of all, let me put this in here. Can I start now? Okay, yeah. Okay, as I mentioned before, my name is Leonardo Micheloni. I'm from Argentina, the three-time football champion. I'm from Argentina, but I live in Spain, near Madrid, in a little town in Toledo. And I work in Together as a software developer / architect. And I am also a Microsoft MVP on development technologies. And I'm also an auth zero ambassador. So that's my background. I'm programming for the last 20 years. So this is the agenda for today. The main goal of this presentation, as we said before, is to have as clear as possible idea of the main concepts on auth. This is a very extensive topic with a lot of details, a lot of specifications. We will just cover some surface details, but I think that will be enough to understand and go deep for ourselves. So how it works, why things are the way they are, what's a client, what's a flow, scope, which one should I use. I may will run off time because it happens to me all the time, but it's a lot of information to cover. But I will try to focus on the basics. So if anything is left out, we can see in our own later. So first of all, let's get started with the topic. Does anybody recognize this screen? This is kind of old. This is a, let's say, social network called Yelp. Nothing special on this. It's just an example. And I don't know if it's still in business anyway. So Yelp, as other social networks, needs people to join. And remember, this is quite old, not too much, but a lot of things have changed since this happened. So in order to do that, Yelp is asking you to invite your friends to join the network from your contact list in other platforms like MSDN, Yahoo, American Online, it's quite old. And so, but if we look closely, the screen is a form that is asking you for your credentials. I mean, your user email and your password to access to Gmail. So I'll give you 2 seconds to think about it. A website is asking you for your email address and your password to access to your contacts. So this is not good. Sorry, I heard something. Okay, sorry.
You can keep going.
Yeah, sorry, I heard something in the background. Sorry. So as I was saying, they ask you for your credentials to access to your email account with your credentials and look for your contacts and send spam or an invitation in your behalf because it has your credentials. And with a little luck, that will be all, let's say. So I made this beautiful diagram about what's going on here, but it's simple. But Yelp is trying to access to our email account to get our contacts. Okay, this is me or you. Just we are not playing in a role now, but if you think this was only a isolated social network, you're wrong. Other websites, like in this case, Facebook, at the beginning, did the same thing, asking you to give them your credentials to access to your Gmail account, Yahoo, Windows Mail, etc. You may think, okay, it's wrong, it's really wrong, but at the end of the day, it's a social network, so not something not so serious. We are quite okay. Okay, but the next screenshot I have is one taken by me. Long story short, since I am from Argentina and I live in Spain, time to time I send money to Argentina to pay some stuff. Doesn't really matter, but this is a quite popular transfer money service. This screenshot may be 2 years old. I hope this has changed. I don't know. So in order to transfer money from Spain, in this case, to Argentina, you need two banks accounts, or at least one. One in Spain, from where you get the money, and another to send the money. But you need a way to access to the money in the first account, in the SARCS account. Okay, this screen is asking you, in fact, it's asking me, my credentials for my bank account. As you can see here, you can change. It's blurred, but you can change the bank and your document and your ID. I mean, and you need to put your credentials so the site can access to your bank account and act as you to get money and send it to the other account. So this is worse, I think. And I hope they didn't store your credentials into their system. I hope. So this is quite the problem. Okay. So what's going on here? Let's think. An external application needs access to some resource. Let's say the transfer service needs access to your bank account to do something, or Yelp need access to your contact list, a resource, let's say. And this resource is in another application. So I improved the previous diagram with some terminology. Facebook, in this case, is trying to access to our email account. Let's call it resource provider because our email account is where the resource is located. In this case, the resource is the contacts. We are the resource owner because we own the resource. Okay, so nothing fancy here, but with more detail and using OAuth terminology, Facebook, a client, tries to access to a resource provider, our email account, to access to a resource, contacts, and in order to do that, needs to log in or to prove identity against an identity provider. In this case, the identity provider and the resource provider is the same application. It's not always like this. For example, we can think about Google, for example. We log in the same screen, the same Google login screen to access to different Google services, Gmail, Drive, etc. This is a good example of a central IDP, identity provider, IDP, with different services or different resource providers. This is a very common scenario, and is a good example of a single point of failure, but not always the IDP and the resource provider are the same application, or I must say it's the less common scenario than the IDP and the resource provider are the same application. Of course, this is quite simplified, but let's go on. So what's going on here again? An external application, a client, needs access to some resource. This resource is in an external entity, a resource provider. So the client needs credentials to get the resource. I'm going slow because this is very important. So there are some little problems as we saw. We are given our credentials to an unknown application. The application will access not only to the resource itself, but to all the resources in the account. I mean, if I am giving my credentials, my email account credentials to someone, it can access to my email address, my emails, send emails in my name, in my behalf, etc. This scenario, the first scenario, is exactly the same or similar to give the cinema hall keys to all the people that want to watch a particular movie. I mean, if you are giving the keys to open the cinema hall and access to one movie and another movie for any unlimited time, is not ideal. But this is quite what is happening here. What if the identity provider gives some type of ticket or token to the client? This token or ticket has no relation with my credentials, like a cinema ticket. This token only allows the client to access to a specific resource, a specific movie, or only to my contacts list. And what if this token has a limited lifetime? For example, 1 hour, the movie in this time, etc. So here's where we start talking about OAuth. This is taken from the official documentation, from the official page of OAuth. OAuth is, first of all, let's clarify the difference between authentication and authorization, because this is quite important. Authorization is when you have a rule to allow someone to access to something. I don't know what I just did. Okay. Sorry. Authorization is authorize someone to access to something, and authentication is is verifying that this person is who really they claim to be, person or resource or client or whatever. So OAuth is an authorization protocol. Only is in charge to authorize clients to access to resources. I highlighted some parts, but the more important is the last one. OAuth essentially allows access tokens. I talk about token or ticket. Let's call it token. In this case, access token, because we are verifying access token, because OAuth has more than one token. Access token because, in fact, we are checking access, allows access tokens to be issued to a third-party client by an authorization server. Authorization server, identity provider is quite the same. It's not exactly the same, but we will use the two words interchanged with the approval of a resource owner. The resource owner, the owner of the resource, has to approve the access. And the third party then uses the access token to access to the resource hosted by a resource server. So this is exactly what we saw before. We have someone that wanted to access to a resource in a resource provider. The resource owns to someone. Okay. This is all OAuth terminology, and it's very important to remember this terminology. So there are several benefits if we do that. No password is compromised. If we give an application our credentials, our password will be compromised. And if we use the same password for different services, I don't do that, but maybe someone. Other benefit is we limit the access in time and resource. We only give access to a particular resource in a particular time window and limited time. And this is similar, as I mentioned before, to give tickets to a specific movie valid on a specific date. So I improved the diagram at an incredible level. So this is the exactly flow that auth uses to accomplish this goal. So we will see this in detail because it's very important to understand, and this is the base for the other interactions. So Facebook, the client is always an application. Users are never clients. The clients are always applications. First important point. Then Facebook asks the identity provider or authorization server for access. The authorization server gives a token. Then Facebook uses this token to access to a resource provider and get access to the resource. The resource provider validates the token, the ticket, the same as in the cinema. It validates the ticket is valid for this date, this resource, this movie, and returns the resource to the client. This is exactly the flow that auth follows, exactly, at least in one case. Again, as resource owner, we are just here watching what is going on in the background. We are not participating in this particular flow, but we will in the future. So let me check my notes. Okay. So in the OAuth world, we need an identity server or authorization server. We need a client, an application. The client is always an application. The user has nothing to do with authorization. We need a resource server that trusts the IDP because the token will be created by the IDP. So, and it's the place where the resources are located. The flow will be something like this. The client starts asking the authorization server, sending credentials. The client has its own credentials for a token. The auth checks some information about the client, returns the token, and then the client requests the resource using this token to the resource provider. For example, we logged in using our Google account, and then using a token, we access to the Drive API or something like that. Then the resource is returned by the resource provider after verify the token. That's it. It's quite simple, but it's very tricky to understand. We will see our first demo. I will check first if I don't have any. Okay, if I have any messages here. Okay, so I will show a demo of this exactly flow, very slow, because as I mentioned before, it's very important to understand the basics. So I have some things here. First of all, I have an API here, nothing fancy. It's just a .NET weather forecast API, classic. As you can see, the code is unimportant. Only this part I have configured the authorization using OAuth, and that's it. It's the standard template when you create a new .NET application. I also have here Postman, and there is a request to access to the API. So if I try to access, I received an authorized response because the API is protected. So how can we, using OAuth, get access to this API? Okay, so let's go step by step. First of all, I have here an identity provider or authorization server. In this case, this is Keycloak. It's a quite standard or popular software. I have here some clients created. I have a session that is okay. I have we won't dive into Keycloak today, but I have some clients created here. I created one here. That is, the ID is CC. Programmers, we are lazy. Then it's configured to use service account roles. That is the name that Keycloak uses to specify the specific flow I'm trying to use. We will see what flows are in just a minute. So this is something that happens all the time. You learn the theory behind OAuth, and then you go and try to use a software like this, like Keycloak or any other, and they change all the terminology for their own terminology, like service account roles is client credentials grant. I mean, why? But anyway, and I have a password. I mean, this will be the username, the client ID, and the credentials is something like a password for this particular client. So how can get access to a token? Okay, I can make a post call to this identity provider with this information to get a valid token, as we saw in the presentation. So how can I do that? I have a collection here with some requests. I'm sharing all this stuff in a GitHub repository, but this is a client credentials request. It's a post request, nothing special. The URL, a particular endpoint, and only 3 fields. Grant type is the type of interaction that I need to perform to get the token, client credentials, the client ID, CC, and the client secret. That's it. If I make the post, I get a token. Amazing. This is token. We will see this in detail in a minute. I can copy this token, go back again to the weather forecast request, go through the headers or authorization, is the same. I will go to authorization tab and select bidder token, paste this right here, and get a result. Okay, what happened here? First of all, the token is like a cinema ticket, let's say, has some information inside. And in fact, we can see this information with no limitations. For example, I can go to this URL. You will get familiar with this when you start to work with OAuth. And I can paste the information just like this returned by the IDP. And as you can see, we can see the content of the token. Important here, expiration. Expiration is in 30 seconds. I mean, yes, it's this minute. Okay, I think this is expired. So if I try to post again, unauthorized, because the token was created for be valid for 1 minute only. So I can make exactly what I said before. I can create tokens with a very short period of time. It's only valid for 1 minute. This is ideal because if someone steals the token, will be valid only for 1 minute, but not always possible depending on the application and scenario. So there are some other information here. We will go back to here in a minute. What happened here exactly? Okay, this is just in case the demo failed. First of all, we use a specific interaction to get this token between the client and the authorization server. This interaction, this flow of post my client ID plus my credentials and get a token is called authorization flow or grant. In this case, client credentials authorization flow or authorization grant.
And Leo,
this is one. Yes.
I think that answers one of the questions that we have from our viewers. So Christoph was asking, like, how does the resource provider know about the token? So you have this
good question. Good question. Good question. Good question. It's a very, very clever question. Tokens. As this person asked, how first of all, how if I can see the content of the token, I know this token is valid and wasn't modified since the IDP created. Okay. First of all, the token has 3 parts, as we saw here. Here we have 3 parts. Red one, this color, strange color, violet, I think, and blue. A header, a payload, and a signature. So how does it work? First of all, the IDP creates the content with some information. The information, it can change, but we always will have the expiration, the not used before, and the issuer who created the token, the subject, the identification of the client, and I think that's it. All the other information is optional. So in this case, Keycloak is configured to add this information, but you can skip it, or you can configure Keycloak to not create this information. Exactly. Okay. So the token is created, a hash is calculated for this content, and then using a private key, a cryptographic private key, the identity provider signs or encrypts this hash and adds it to the token as this signature. So with a public key, the resource provider can know that the token was created by the identity provider. I mean, asynchronous keys works something like I have a private key and a public key. If I encrypt something with my private key, the key that only I have, I encrypted something with this key. Anybody with my public key, that is public, is not important, can decrypt this information, but cannot encrypt information. So if you have my public key, you can be 100% sure that this information was created by me and wasn't modified by anyone else without the private key. So with a private key, the content is signed. This signature is verified by the resource provider using the public key. And the question was how the resource provider knows about the IDP. There's something I didn't say, but it's a very good question. That's why it's a very good question. When I configure this here, in this case, this is particular of ASP.NET. Depending on the technology, the name of this property can change. But in this case, when I set up this URL here, this is the URL of Keycloak, let's say. So automatically, .NET checks this URL and gets the public key. How? Okay. I will talk about it in 2 minutes, but let's see it now because it's very interesting. It's very interesting. If I can find, okay, here. Realm settings here. If I go to here, this is the same URL is configure in ASP.NET, and then this is standard. We will see it in a moment. This is standard. So when I put this URL here, ASP.NET, because it's standard, knows how to add, or knows that, sorry, that adding this can access to this information. This information is a standard of the protocol. And here you can find the public key. The public key is here. I don't remember exactly where, but you have the URL of the public key in some place here. But this is how it works. Basically, the resource provider needs the URL of the IDP to get this metadata, or discovery endpoint, and get the tokens. In fact, if you look closely, this page knows that the signature is correct. How? Okay, you can see signature verified. How it happened? This happened because this page read this URL, and did the same. Added the /.well-known slot OpenID configuration part and gets the public key and verify the signature automatically. I don't know if we can see it if I do it again, but it's just like this. So yes, here. You can see, as soon as I paste the information, this page go to OpenID configuration endpoint to retrieve the certs. Here's the response, and then another request to get the keys. Then, using these keys, the resource provider verified that the payload wasn't changed. So it's a very clever mechanism. So these type of things are very important, because when you try to configure for the first time all this stuff, if you have something wrong or something, for example, I found some problems working with the Graph API, because the signature mechanism is quite special. And for example, if you try to paste a token created by the old Graph API, this will fail, because I think the algorithm is not standard. In the header, you can find here the algorithm used to create the hash. But this is how the resource provider knows that the token was created and wasn't modified. Okay, good question. So next, here. Okay, so this is exactly what I was. Okay, so as I said before, this particular interchange of information between the client, in this case Postman, and the IDP is called client credentials authorization flow, or authorization grant client credentials. It's very popular because it's the only one that we will use always for this type of scenarios. We have an application with no user interaction that tries to access to some API. For example, if you try to create an application that can access to, let's say, some Google API or something, you will be asked to create a client and client credentials and stuff. That will be the case. So, but OAuth has several flows: implicit flow, code flow plus PKCE, resource owner, device, hybrid. We won't cover all the flows because, as I said, when I start, we will run out of time. But we will see the more important. You may notice no human has participated on this operation because client credentials is for robots or applications. The question is, when we need a human to interact. Okay, this scenario is more similar to the previous, to the Yelp thing. This is, for example, this is a sessionist site, is a website that asks us to register. So we can register in the old way using a username or email and password. Maybe a verification link will be sent. We need to create a new password following some security criteria, etc. So we may use the same password we use in other services because we are lazy. So this is okay. But as everyone knows, this is tedious and maybe a deal breaker for new users to join. So the question is, how can I use OAuth to avoid to have to complete all the information that I already complete in other applications? Okay, this is why OAuth is useful.
Leo, if you don't mind, I have a question I want to pop up on the screen.
Tell me.
Here. We have a viewer asking about checking the expiration time of the token. Who's responsible? Which component in this flow is responsible for checking expiration?
Very good question. Very good question. At the end of the day, the resource owner is who's checking the token. I mean, if I receive a token that is out of the time when it's valid, is responsibility of the resource owner. In fact, if you see here, I added this parameter because by default, ASP.NET has a toleration time that I think is 5 minutes after the token is out of time. So I put it to 0 so my demo work. But this is responsibility of the resource owner, the resource provider, because it's who is checking the token. This is interesting because it was hard to find this. By default, there is always a period of time that it doesn't matter if the token is out of the valid time, because I just created the token and I used the token 1 minute after it was created and was valid for a minute, and to avoid these cases, edge cases, you always put a toleration time. So it's responsibility of who is consuming the token. Yes. So as I was mentioned, this is the one of the more interesting scenarios. I need some information for a user. I mean, I want users to register in my site, but I don't want they to have to fill all the form, the name, the username, all this stuff. So I can ask someone else that already knows this information to fill automatically this information. So, for example, in this case, I added these social network buttons, and what happens behind the scenes is exactly OAuth. When you press, for example, the Microsoft login button, you will be redirected. As you can see, the URL has changed here. I was in sessionist, and then when I press Microsoft, I was redirected to the Microsoft login page. Then when I logged in using my Microsoft credentials in the Microsoft site, using all the multi-factor authentication, all the rules that I have set up before in this particular IDP, I get returned to the previous screen with my information field. How does it work? This is very clever. As I mentioned, but okay, the application needs to register to okay. To avoid the process of entering our email name, etc., it will ask someone else that already knows this information. In this case, any of these networks or applications. So how does it work? This is the flow. We will see a demo in a minute. The user, a person, clicks on, let's say, Google button. Then the client redirects the user to the auth server, in this case, the Google account or Microsoft account. When the user enters valid credentials, is redirected again, is redirected to the Google screen, enter credentials, the credentials are validated by Google or Microsoft, and a token is returned to the client with some additional information. For example, the name and the username exactly, and so on. So we need the participation of a user because the information owns to the user. We need a web browser because internet, in the previous case, in client credential case, we didn't need a web browser. We need to redirect the client so the person enters credentials and authorize the client. Then the token is returned with additional information. This flow is called implicit flow. It's important. So let's see a little demo about it. I have this API. I won't use API. I have here an Angular application. This is just an example I found on the internet that I just modified here. I modified the configuration to use as authority my key cloak. I put this information, okay, sorry, the name of the client and some other stuff that we'll see in a minute. So let's first of all check the configuration. Here, key cloak, I will close these screens. In key cloak, if we go to the client tab, we'll see the implicit client that was created by me 1 hour ago. So the name is implicit, and there are two very important pieces of data here. The redirect URL. As we saw before, after the user logs in, the IDP redirects the user again. Where? Here. This is very important because I think 90% of the cases that I find some OAuth configuration invalid is because of the URL, the return URL. And it's very important because in the return URL, as part of the return message, the redirection, the HTTP redirection is the token. So this is very important. So this is the logout. It's not so important, but it's important. This is the main piece of data that we have to set up correctly. So we don't have the credentials tab because we are in a browser. We can use credentials in the browser because that will be ridiculous. So client ID and redirect URL. And if I go here and paste this URL, I will copy. I know that if I press Ctrl+C, I will stop the website. No, okay. Let's go here. Let's go to Chrome. And let's see what happens. Where is this? Here. Okay. Network. Paste it right here. I was redirected to the IDP. So the first step we saw before. As soon as we don't have the login with key cloud button, but it's automatic. But it's exactly the same if I press a button. And in the redirection, there are some interesting information. Let's put it in a notepad. Key. Client ID, implicit, and redirect URL. URL encoded, but the URL. Okay, so the two main information parts. So I enter my credentials. I have a user called Leonardo because I have a lot of imagination. So and if I click here, sign in, I am redirected again to the redirection URL. What happened behind the scenes? Exactly that. I was redirected to my IDP, and after I enter my credentials, I was redirected to the redirection IDP. And as you can see here, this is the redirection. And as you can see here, I don't know if you can see it because it's very small, but the token is right here in the URL. This is important because this is access token here. This is token, and we can see this token and paste it and look inside it. In this case, because when I configure the client, I ask for a special scope. Scope is the same, is a name for resource. I mean, I can have a resource that is, let's say, my contact list, and I can call it contacts, or an API. I can call it read API, and for administration matters, I can call it admin API, and then I can ask in the client for this particular scope. This scope is called OpenID. This is a standard name, and it means information about the user. So when I get a token from the IDP, the user information is in the token. As you can see, I have the given name, family name, the email. So a website like Sessionist can use this information to fill the sign up form, and that's it. It's done. So very interesting. But this is okay. Okay. So in the presentation again is something failed. I have some screenshot that I previously took. Same here. Okay. To have in mind, the redirect URL is very important. It's the most important part. The redirect URL has a token because it's a redirection. So we cannot refresh the token. It's not allowed to refresh tokens. I mean, if the token is only valid for a period of time of 1 hour, after this hour, the user will have to log in again. Okay, so if I set the lifetime of the token to 2 weeks, if someone steals the token, game over for 2 weeks. Because have you seen the IDP doesn't store the tokens? The tokens are automatic validated by the resource server. How? Checking the signature. So the resource provider never asks the IDP if the token is valid, only checks the signature. So if a token is stolen, it's basically game over. Okay, so refresh is not permitted in implicit flow because implicit flow has this little drawback that we cannot use a secret because it's a web browser, and since the token is returned in the redirection, an interception is possible, for example, in a public Wi-Fi, or the URL will remain in the history of the browser because it's a URL. Or if we are using something like a Google Chrome session, they will share between all the PCs where I'm using the same browser with the same user. So this is no ideal, but this flow was designed in a moment where browsers were more limited. For example, the CORS standard didn't exist or wasn't so popular. So at this point of the history, this was the best option. So now it's not more recommended. And as I said, we are running out of time. So what is recommended? Code flow. What is code flow? I will be a little more of speed. Code flow is an improved version of implicit flow. It's quite the same. I press a button, or I'm automatically redirected to my login with my client ID, my callback URL. It's the same as the implicit flow. Maybe a consent screen asking me if I wanna give my email address and my username to the Facebook site, etc. And then in the redirection, there's no token. There is a code, a one-use code, temporal one-use code. This code is not important. It's only used in a second stage for the website, the same website, to ask again using client ID plus code for a token using a post Ajax call. So no redirection here, no URL compromise, and this is more secure. Again, the redirection where in the implicit flow we had the token. Now we have a one use only temporal code that only verifies that the user logs in correctly and accepted the consent screen, and we can use it with our client ID to get a valid token, and that's it. And we can use the token information or use the token to access to some resource, etc. So that's why code flow is recommended against implicit flow. Implicit flow is not recommended. If you can avoid using implicit flow, you must use code flow. So, but there's a, well, I will skip that. There's here's the post. Here's the redirection, and here's the post made by the code flow behind the scenes. An additional configuration in Keycloak will be besides the valid URL, web origins. Again, depending on the IDP we are using, this name may change, but basically here we have to put the valid course origins. When we use course, we need to set up the server to allow certain clients. So we have to add it here. It's another very common problem, the URL with our own setup. So let me check, because I can see the screen. Okay. Okay. So considerations on the code flow. The redirection after login contains a unique one-use code. The code is used to request a token via post request using Ajax calls. CORS must be supported. A token is not compromised and is preferred option today against implicit flow. So, but there's anything else that is PKCE. Code flow is the preferred option over implicit flow, but there's an extension called PKCE that is recommended. Finally, the recommendation is use code flow with PKCE. What is PKCE? In short words, PKCE is like this exactly like this, but we add a unique, let's say, password or random number here in the first call. Then the code is returned, and when we perform the request, the token request, we add the same, or not exactly the same, but a piece of information related with the first code we use here in the first request. So the IDP can know exactly that the person that is asking for the token is the same that started the first request. So this is PKCE in a few words, but it's an extension over code flow. So OpenID Connect. It is simple. We are running out of time, but this is simple. OpenID Connect is OAuth with an additional layer to perform authentication. We have OAuth. We can get tokens. We can get some information about tokens, but we don't know exactly about the user. I mean, we have some information in the token, some claims with some information, but we don't know all about the user, or we cannot validate the user. So OpenID Connect basically adds some extensions to OAuth. It's the same. So you will hear that people use OpenID Connect or OAuth, and it's talking about the same, because nowadays everybody is using OpenID Connect. In fact, nobody is using OAuth only. So it's the same. Basically, it's an extension and adds some predefined scopes. We talk about scopes. Scopes are what I want to get, the resource name I want to get from the resource server. So add some predefined scopes for X for data. For example, OpenID, user profile, and email. This is the scope that we used before. In fact, when I shown you the code flow demo, I was using OpenID Connect, not OAuth. OpenID is basically telling the IDP also give me the information about the user. User profile is the information about the user plus the email plus etc. etc. Some predefined scopes. That's it. And adds an additional token. We talk about the access token, the token that is used to access to some resource, but we add an additional token called ID token. In this ID token, we have all the information of the user, maybe the address, the job, etc., etc. All this additional information is received in form of claims, and discovery endpoint, the endpoint we saw before. That's why I said that I plan to ask about it later. The discovery endpoint, the endpoint with the metadata, the /.well-known.OpenID configuration endpoint. This is a part of the OpenID Connect specification. It's a standard, so always it's always the same, the URL and the content. And the consent scheme is also part of OpenID Connect. That's why I say that I don't know nobody that is using OAuth without OpenID Connect, because it's free basically. And the user profile endpoint. This is new. We have an endpoint that is called user profile that gives you, in theory, the ID token with all the user profile information. So OpenID Connect is basically OAuth with some standard scope predefined to ask for user information, and an additional token with the user information and the discovery or metadata endpoint. And that's it. Basically, the OpenID configuration endpoint or the metadata is something like this. As you can see, we are here describe all the endpoints. For example, the token endpoint. And when you set up a client, like I set up the Angular application before, I only set the root URL, because this library automatically knows how to search to add this part of the URL and look for this information, and then they can know the token endpoint, protection endpoint, user info endpoint, etc. This can change, so the standard only defines this, and obviously these keys, but you can change these endpoints, and also we can find here the flows supported by the IDP and a lot of other things like response types and also the keys, the cryptographic keys, as we saw before. This is an example of the token endpoint, and this is the consent stream that we saw before. This consent stream is part of the OpenID Connect protocol. It's basically asking you to authorize an application to access to your information, because when you set up a client to access to a user information, depending on the configuration of the IDP, may show a consent stream like this, depending on the data you want to get for the user, from the user. And then the last one is the user info endpoint. That is an endpoint that you can access using the access token and get information about the user. Here you can find all the information about the user. This is the other thing that is added by the standard, and the search endpoint that we can see here, that, as we checked before, was used by the .NET application to get the certificates, the keys, and verify the token. Obviously, the user info information gives you information about the current user. You cannot access to other users' information because that will be wrong. So, one last thing, what we haven't seen today, PKCE in deep device code flows refers token in a lot of details, because, as I mentioned when I started, this is a very extensive topic with a lot of details, and I I like to talk a lot, and I don't have the ability to be so punctual in my explanation. So it's what I had for today, guys.
Thank you very much, Leo.
I don't know if you are still there.
Yes, we are.
So again, thank you, Leo, for sharing all your expertise there with the audience. And thank you to our viewers for tuning in to the On.NET live show. As a reminder, if you want to watch recordings like what you saw today on this stream, you can do that by navigating to dot.net/live in your browser. And if you tune into the show next week, we'll be joined by guests Jody Donetti, and the topic will be Fusion Cache, which is Jody's open source project. We hope to see everyone then, and thanks again.